Rahim. Dear students, Assalamu alaikum. So today we have to solve another question related to capacitance of capacitor. It is problem number 3 in the 10th edition of Halliday, Resnick and Walker Fundamentals of Physics. The video is purely for the educational purpose. The question is, a parallel plate capacitor has circular plates of radius 8.2 centimeter. The shape of the plates is circular, so their area will be according to the area of circle and 1.3 centimeter separation between them. So D is 1.3 centimeter and the radius of each plate is 8.2 centimeter. So area of each plate will be pi r square or pi into 8.20 square centimeter square. If we want to make it into meter square, then it will be 10 to the power minus 4. So calculate, A part is calculate the capacitance of the capacitor. B is what charge will appear on the plates if a potential difference of 120 volt is applied. So first we will find the capacitance of the capacitor. The given data is radius of the plates is equal to 8.2 centimeter, which can be written as 8.2 into 10 raised to minus 2 meters, and the separation between them is 1.3 millimeter. It is actually millimeter, which is equal to 1.3 into 10 raised to minus 3 meters. So it is in millimeters. Separation is in millimeters. So we have to find the capacitance. The capacitance of parallel plate capacitor, we know the formula is capacitance is equal to epsilon naught A over D, where epsilon is the permittivity of free space, A is the area of each plate, and D is the separation between them. Since the plates are circular in shape, therefore area will be equal to pi r square. R is given as 8.2 centimeter or 8.2 into 10 raised to minus 2 meters. So area will be equal to 3.142 is the value of pi, or you will use the value of pi given the stored in the calculator, into r square is 8.2 into 10 to the minus 2 meters, so it will be equal to meter square. So we have to take the square of r of this. When we use calculator to find it, it comes out to be 0.02112 centimeter area of the each plate. Okay, now we know the area, we know the separation. Put the values in the formula to find the capacitance. The capacitance will be equal to C is equal to epsilon naught A over D. So C is equal to, we will put the values. Epsilon naught is 8.85 into 10 to the minus 12 into the SI unit, whatever, into A is 0.021122469 meters square over the separation is 1.3 into 10 raised to minus 3. All of the units are in meters. This is also meter. This is meter. Okay, it's a meter square and is a meter. So capacitance will be equal to, when we simplify it with the help of calculator, the answer comes out to be 1.438 into 10 to the minus 10 meters. If you want to make it, shift it here to the decimal, you can round off this to 2 decimal places. It will be 1.44 because A is more bigger than 5, so the 3 will become 4. So we'll get 1.44 into 10 to the minus 10 meters. If we want to take it into picofarad, then we have to make it 12. In order to make it minus 12, we have to shift this decimal places 2 digits towards the right hand side, so it becomes 144 into 10 raised to minus 12 farad, or it can be written as minus 10 power minus 12 is pico. So capacitance of the capacitor will be 144 picofarad. The correction should be, one correction is there, this is in actually sorry, this should be in meters square, so it is in meters square. Okay, now we have found the capacitance, which is 144 picofarad. Now second part is we have to find the charge accumulated or stored on the plates when a potential difference of 120 volt is applied. So we have to find charge. We know the formula for charge on the plate of a capacitor is equal to Q is equal to CV. C we just found as 144 picofarad or 144 × 10⁻12 farad. So we put the values here. Q is equal to 144 × 10⁻12 because we use the SI units, so it is 10⁻12 farad into 120 volts. So farad into volt will give you coulomb. So when we multiply it and simplify it, it comes out to be 1.73 into 10⁻8 coulomb. To make it 10⁻9, we need to shift this to one decimal to the right, so it becomes 17.3 into 10⁻9 coulomb. 10⁻9 is prefix is nano, so Q will be equal to 17.3 nano coulomb. So this completes our problem number 3 of the Halliday resnick worker, chapter number 25, which is about the capacitance of the capacitors. I hope you understand. If you have any query, you can ask me in the comment section. If you are new to my channel, please subscribe to my channel and also press the bell icon so that you can get all the notification of my coming videos. Stay tuned to Belief Physics for more informative and scientific videos. See you in next video. Until then, Allah Hafiz. Bye. Take care.